Myself, Mrs. M. Vijay Sabrishwari, working as an assistant professor in ECE department in Sri Shanmuga College of Engineering and Technology. Let's see interrupts of 8051 in today's class. 8051 interrupts. So what is interrupts? So interrupts are nothing but it is an external or internal event that interrupts the microcontroller to inform it that a device needs its service. For example, our microcontroller is connected with several devices. Each device needs the microcontroller service whenever it is needed. So that is given as an interrupt signal to the microcontroller. So then how can a microcontroller can serve to the several devices? So it uses two ways, interrupt and polling method, to handle the interrupt signal from the various devices. So let's know what is interrupt and polling method. So in interrupt method, whenever any devices needs its service, the device notifies the microcontroller by sending the interrupt signal. So upon receiving an interrupt signal, what the microcontroller do is complete the running operation and serves to the devices what it needed the interrupt signal. The program which is associated with the interrupt is called the interrupt service routine or interrupt handler. So in interrupt method there is a software called interrupt service routine that will handle the interrupt signal from the various devices by using some priority method or some vector routing method. So the interrupt service routine has a priority table. So based on the priority, whenever the interrupt signal comes to the microcontroller, the interrupt service routine call upon the interrupts based on the priority, or else interrupt service routine have a vector table of the interrupts. So based on the vector table, it will call upon the interrupt signals. So that is the interrupt method to handle the interrupts. So another method is polling. So in polling method, the microcontroller continuously monitor the status of the given devices. So if three devices are connected to the microcontroller, all the three devices status will be continuously monitored. So whenever the device need the service, microcontroller do the service for that devices. So due to that, microcontroller wasting its time by continuously monitoring. When the condition met, it perform the services. After that, it move on to the monitor duty. So every time it doing the monitor duty, so which device needs service, that service will be immediately given to the devices. The polling method is not efficient because wasting of the time. So the advantages of interrupt is that microcontroller can serve many devices not at all the same time, but whenever the device calling the needed the service, that service will be provided by the microcontroller with the efficient time without wasting the time. So how it means? By assigning the priority. So for the polling method, not possible to assign priority, that is why it continuously monitoring either round robin fashion. So microcontroller can also ignore if any important or priority request is called. The polling method will ignore that request. That is the one more disadvantage of the polling method. So what are all the interrupt signals available for 8051 or reset? That means power up reset. Two interrupts are set aside for the timers. We have two timers, timer 0 and timer 1 in 8051. So we have two interrupt signal individually for the timers. Two interrupts are set aside for the hardware external interrupts, that is int 0 or external interrupt for timer 1 or timer 2 devices. Then serial communication has a single interrupt that whenever it is needed the receive or transfer condition, that condition will be given as an interrupt to the devices. So what events can trigger the interrupt means timers, transmission, either reception or transmission. Then external events, out of the devices, if any external inputs are given to the microcontroller from the user. So these are all the interrupts that can trigger the interrupt. So 8051 interrupt vectors. So in this, every interrupt signals having a vector address. So this vector address is stored in a vector table that is used by the interrupt service routine, that is ISR. For example, external 0, the interrupt vector address is 0003H. External 1 means 0013H. So based on this vector address, it will do the continuous service to the interrupts. 8051 interrupt related registers. So what kind of registers used specifically for interrupts are TCON register, SCON register, IE register and IP register. So TCON registers mainly focusing on external interrupts happen to that timers. So TCON means timer control register. SCON means status control registers. So based on the what kind of status means transmission side reception is needed, transmission is needed. That kind of signals will be handled by SCON register. IE interrupt enable. So if we don't want to interrupt the program, then we can disable the interrupt services by making the IE pin as disable. If IE is disabled, nothing will be interrupted to that existing program. Then IP, specifying the priority of interrupts. We are giving the priority signal based on the by using the interrupt priority registers. So IE register, that is using the enabling and disabling an interrupt. So upon reset, all interrupts are disabled, that is masked. That means masked interrupts or will not be performed, meaning that none will be responded by the microcontroller even though if they are activated. The interrupts must be enabled by the software in order for the microcontroller to respond them. There is a register called interrupt enable register. So to making the interrupts masking and unmasking. So interrupt enable register. So in that we can clearly see what kind of signals are stored. So EA, global enabling and disabling pin. ET1 and ET2 are used for enabling the timer interrupts. EX1 and EX0 are used to enable the external interrupts, and ES is enable the serial port interrupt. So ET2 and ET1. So both are used for timer 1 and timer 0. So EX1 and EX0, external input 0 and 1. So how we can disable or enable an interrupt? In this slide, we have an example to enable and disable. So for example, set B is used to enable. Clear signal is used to disable the interrupt. So set B interrupt enable at the 7th pin is equal to EA equal to 1 means the global pin. So our 7th pin is nothing but global enable or disable. So we have set of the 7th pin, that means our global enable pin is goes to high, so we can service to the interrupt signal. 4th pin is nothing but serial interrupt. So if we set IE.4, that is 4th pin is setted, that means made 1, then serial interruption can be handled. The same way, first pin, second pin, or in our register there are 0 to 7, there are 8 bits. So each bit have a special function. So we can specify the number. In this way we can set or clear the IE register. So clear is used to disable the signal. The same way, set for enabling the signal, clear for disabling the signal of the respected pin 0 to 7. Next one is interrupt priority. So interrupt priority means if we have so many interrupts, so we have to assign some priority. So based on the priority, the interrupt signals are serviced. So that is called interrupt priority. So for example, here the tabulation is given as highest to lowest priority. That means external interrupt has the highest priority. The second highest priority is timer signals. Then the third highest priority is external interrupt 1. Then fourth one is timer interrupt 1. Then fifth one is serial communications. So based on this order, if two or more interrupt signals called the microcontroller, what will happen? Microcontroller check the priority, then it performs the service based on the priority. So we can alter the sequence of interrupt priority by assigning the highest priority to any one of the interrupts by using the interrupt priority register. So this is the interrupt priority register. So we can change the priority levels by using this register. We can change the order what we needed. So based on this priority register mentioned, the interrupts will be performed. So here the 3, 5, 6, 7 all are reserved. That means we can the user can used for accept this priority signal. If the user has some more interrupt signals means we can add it in this 3 bit. So PS is serial port, PT1 and PT2, PT0 are for timer 1 and timer 0. The same way PX1 and PX0 are external 0 and external 1 interrupts. So we are allocating the priority levels for the 5 signals. Only these 5 signals are mentioned in this priority register. We can add 3 more priority signal in this table. So based on this priority, the microcontroller will perform the service to the devices. Okay, thank you.